Okay, good evening, students, and welcome you for another important class lecture on transition elements. We are now coming to the important compounds of the transition elements and some of the most important compounds which are in our course and are being used in chemistry lab also, students. We are going to discuss two important compounds of transition elements. As you can see, I will be discussing two important compound. One, you are familiar with potassium dichromate, student. You have seen this orange type of crystals in the chemistry lab. Another one, potassium permanganate. These two compounds are very, very important and are also used in as oxidizing agents in the organic chemistry and in the chemistry. You have seen that in acid and in basic medium, they are being used as oxidizing agents.
Yes, sir.
And they are also used for preparation of many azo compound, student. And therefore, it becomes necessary to study how do we prepare them. And one question is always given on either of these two. Important point. One question will be there in the paper from these two compounds. The structures of what type of dichromate ions and manganate ions, we will see that. And also, how do we prepare, student? How do first thing is the preparation. We are talking of preparation of potassium dichromate, K2Cr2O7. We have to prepare this. And there is a ore actually which is called the chromite ore. This is chromite ore is we have already written here what we will prepare preparation from chromite ore. We have to remember these things now. Preparation from chromite ore. I am saying. What ore? Chromite ore.
Chromite ore.
This we have to learn these things now. There is no other way out, and that is FeCr2O4. FeCr2O4 is our chromite ore. So what will we do with the chromite ore? What you will see that there is a fusion. What we do is a fusion reaction. Fusion with alkali NaOH or Na2CO3. They are fused in the presence of air to form a very important compound, student. What happens is that FeCr2O4 is reacted with sodium hydroxide or sodium carbonate in the presence of air. That means oxygen is present. So reaction will take place, and first reaction which takes place is shown here, student. This is the first reaction. This process is called fusion when you heat with alkali in the presence of oxygen. This Cr2O4 is our chromite ore. This is our chromite ore, student. And what you are getting is Na2CrO4. What is Na2CrO4, student? What is that? If I see, this is sodium ion and this is CrO4 2 minus. So you have chromate ion CrO4 2 minus chromate ion which is formed, student, here. This sodium chromate, important thing is to note down the colors of these. In the papers, they will
Okay.
talk of colors. Sodium chromate Na2CrO4. This is a yellow in color. You will get, student, a yellow solution. So sodium chromate is something like dissolved in water, aqueous. It is a yellow colored solution, student. First thing is to form sodium Na2CrO4. So sodium chromate is formed. What we are looking for, K2Cr2O7. What we are preparing?
K2Cr2O7.
Cr2Cr2O7, it will have Cr2O2 2 minus. These are called dichromate ions. And you have potassium ion. This is our dichromate ion. What we are getting? Yellow color chromate ions. Yellow color. This is yellow colored solution, student. Yellow colored solution. So we have
Okay.
written this equation NaOH. So when what will we do, student? This is acidified with sulfuric acid. This is acidified with sulfuric acid. So the yellow colored solution is filtered off. This is a yellow colored solution. This will remain behind. Filter it off, yellow colored solution, and you will sodium chromate solution, which is yellow in color, is filtered and acidified. It is reacted with acid like H2SO4, student. So what will happen when you react this with H2SO4? The result is the formation of sodium dichromate. Sodium dichromate, orange sodium dichromate. This is orange in color. What you are getting now, what I had Na2CrO4, I am reacting this with acid, H plus. And what you are getting, student? Na2Cr2O7. So this is sodium dichromate. Na2Cr2O7 will be what? Sodium dichromate.
Sodium
It is
dichromate.
orange in color. Color change is very important. Here I am again repeating, orange sodium dichromate will be there. This can be crystallized. This will be crystallized into Na2Cr2O7 2H2O. So this is orange color crystals. What we will do, orange color crystal. How do chromite ore fuse with sodium hydroxide and oxygen? This process is our fusion. I will heat it with sodium hydroxide oxygen. I will get sodium chromate, yellow color solution. This is filtered off and treated with acid, and you will get sodium dichromate. But what you want, you want potassium dichromate, not sodium
Potassium dichromate.
dichromate. So you will take equimolar proportions of hot solution of sodium dichromate and KCl. I will mix with KCl. What happens? Potassium replaces sodium, potassium replaces sodium, and you will get potassium dichromate crystals will be formed, student. The sodium dichromate is more soluble than potassium dichromate. So therefore, we prepare it by reacting with potassium chloride. What will be the result of
Okay.
this? Orange crystals of potassium dichromate crystalline out. Orange crystals of K2Cr2O7, they will be formed, student. We can obtain orange colored crystal of potassium dichromate. Now this is important reaction. I mean, has been asked preparation of potassium dichromate many times in the paper, student, many times
Okay.
from the chromite ores. Or in a different way, it has been asked that there's a chromite ore is reacted with us, is fused with alkali in the presence of air. They will say yellow color solution is formed, and then this yellow color solution is acidified and treated with KCl to get orange crystals. Give the formula of these. Write down the
Okay.
formula and equations. So questions are put in many ways.
Okay.
Therefore, we should be able to identify that potassium dichromate, which is crystalline out, is the orange colored crystal. The two important point to note here is that you have two ions which I am talking about. One is CrO4, student, which is my chromate ion, CrO4 2 minus. This is what we are calling
Chromate ion.
chromate ion. And the other one I am talking is Cr2O7. This is our dichromate ion. Dichromate ion. Here there are two things, two ions, dichromate ion and chromate ion. The color of the two is different. This is the important point. Important point. Color of the two are different. Okay. All right. What I am saying that you have CrO4 2 minus. This is my chromate ion. Chromate ion. If we want to draw the structure, one question was there on the draw the structure of chromate ion. Draw the structure of chromate ion. You have only 1 minute to attempt. Draw the structure of the chromate ion, students.
Okay.
Here you have chromium. This is my chromium. Now what? How many bond pairs are being formed, students? What is the chromium? This what is the oxidation state of chromium here?
Chromium here would be
Or
x
6, 4
minus
to the 8.
8 is equal to minus 2 plus 8 plus 6.
Chromium is in +6 oxidation state. Chromium is in +6 oxidation state. This is a chromate ion. Chromate ion, students. So what will be the shape or structure of CrO4 2 minus, students? I've drawn it in yellow color because it is yellow in color. Yellow in color. This color is important. Color is important, student. Yellow color. What is the atomic number of chromium, students? Scandium, titanium, vanadium, chromium. Scandium, titanium, vanadium, chromium. How do we write chromium? What was chromium? 4s1 and there were 3d5.
Chromium is 24s1 3d5.
4s1 3d5 6 chromium 6 plus. This is a chromium 6 plus oxidation state, students. How many bond it is forming here? Bond pairs are 4.
4.
So therefore, what will be the result of that, students? It will be what will be the story of this chromium? This will be tetrahedral.
Okay.
Tetrahedral structure. If it is tetrahedral, then can we draw the structure of CrO4 2 minus, students?
Yes, sir.
CrO4 2 minus.
Yes, sir.
What is the hybridization?
There are 4 bond pairs.
sp3. This is
sp3.
sp3 hybridization. And then how it will look? CrO4 C. You have 2 minus charge. You can see there are 4 oxygens. Something like this. This is the structure of the chromate ion, students.
Yes, sir.
But there will be resonance. There will be resonating structures, as you can see, because these bonds can shift, student. If I fix one, you can see that double bonds and these can interchange. So there will be many resonance structures. There will be many resonance structures. And all the chromium oxygen bonds have been found to be equal. That shows that there is a resonance between this. There are many possible resonance structures of CrO4 2 minus.
Okay.
Even the paper they said draw the structure of CrO4 minus. This has been asked in the paper. That's why I am given it. Draw the structure of chromate ion. This is a tetrahedral and you can see sp3 hybridization. This is one possible structure. There are many other because I can shift the position of the single and double bond, students. And all the bond lengths have been found to be equal. All CrO bonds equal. all CRO bonds have been found to be equal. Have been found to be equal, students. So this is yellow in color. The question has also been asked, what is the reason of color of this? Why CrO4 2 minus, student, is yellow in color? What is the answer you are giving? The question was asked in the paper.
Uh,
This is chromium plus 6. In the plus 6, there is no electron. So these are not due to DD transition. The color is not due to the any DD transition here. But
okay.
the color is attributed due to charge transfer. There is a charge transfer, student. Is a different reason for the color. Yellow color
Okay.
is not due to DD transition. This is due to charge transfer. This important point. The color is due to charge transfer, students. Important point in these cases. Important. This is not, there is no DD transition in the case. What happens is the oxygen atom donates electrons to the chromium metal, which is there, metal atom.
Okay.
So there is a transfer of charge from oxygen to metal momentarily. Therefore, there is a color which is yellow in color. These are called charge transfer from
Okay.
oxygen to the chromium metal. So there is a charger transfer of charge from oxygen, students. Oxygen gave its charge to the, where is a metal atom here, chromium. Color could also be due to the charge transfer. In these compounds, there is a color which is due to the charge transfer. All right, structure we can draw.
Yes, sir.
Let us see the story of the dichromate, student. Dichromate ion, dichromate ion. This Cr2O7 2 minus. This is orange in color. Orange in color. This is yellow. And important thing is that the two ions are interconvertible. Dichromate and chromate ions are interconvertible, students. Chromate or dichromate are interconvertible in aqueous solution depending on the pH of the solution. Important point. I am saying Cr2O2 minus and Cr4 2 minus. They are interconvertible.
Okay.
Now question has been asked here. And it depends on the pH of the solution. It depends on the pH of the solution. So when the pH will change, then the color will change, because the color change means, yeah, if it is yellow, then which ions you are having? Chromate ions. If it becomes
Chromate.
orange, then
Dichromate.
dichromate ion. So all the thing you are saying, this is your dichromate 2 minus. When it, this is my water, student. Here there is an equilibrium at pH 4. There is an equilibrium. What ion you are getting? You are getting 2CrO4 2 minus and 2H plus. That means, student, this is a reaction, orange, and this is yellow in color, orange and yellow in color. So what will happen? If you add acid, What will happen? If I add acid, pH will decrease.
Hmm.
pH will
Yes,
decrease,
sir.
then H ion becomes more. Then what will
More.
happen? If H ion is increased, which side it will shift, student? Which side it will shift? This is more than Le-Chatelain principle will drive it towards this side. So what
Okay.
will happen? Chromate ions will get converted into dichromate ions. Chromate ions will get converted into dichromate ions. Important point to note, what is the oxidation state of chromium in here? +6. What is the oxidation
Plus
state of
6.
chromium in Cr2O7?
It is 2x minus 14 is equal to minus 2. 2x minus 2 plus 14. Uh, plus 6 only.
Both oxidation state is same.
Yes, sir.
Oxidation state is same, students. Important point to note is oxidation state is state, but equilibrium exists. And if I will increase the H ion concentration, if the pH will decrease, then it will move towards the dichromate ion. And if I will remove these H ions, if I remove these H ions, student, what will happen? Then dichromate will get converted into chromate ion. Chromate ion. So that is an important point, student. It has been asked in the paper. There is a question here. We are spending time because there is a question here, student. Can we draw the structure? What is the color? Why the color changes if I add acid or if I add some alkali? What will happen? Then this will get neutralized and then it will move to the forward direction. So what will happen? Then it will become yellow. From if it is yellow, then what ions are there? Chromate ion. So the two ions are
Chromate.
interconvertible and they can convert one into other depending on the pH of the solution. The question has been asked.
Okay.
That means if I add alkali, what will happen? If I add alkali, students, then the result is this will be used up and dichromate ion will go into chromate ions.
Chromate ions.
And if you add acid, then chromate ion will go into
Dichromate
dichromate
ions.
ions. So if that they write like this, CrO4, student, in the exam, 2 minus plus 2H plus. You have to complete the reaction, students. Complete the reaction, or in other I say Cr2O7 2 minus and 2OH minus. What is the result of this? Chromate with H plus. Chromate with H plus gives what? Cr2O7 2 minus
7 minus.
and H2O. And dichromate with OH minus, 2OH minus gives
Chromate. Chromate.
chromate ion and H2O. So here certain type of questions can be asked.
Okay.
All right, this is
Yes, sir.
important information. This is a very important. Let me tell you, one question is always there in the paper from potassium dichromate and potassium carbonate. Always I am saying that means it will be there. And the most important thing we are aware is that this potassium dichromate, what is the structure of potassium dichromate, students? What is the structure of Cr2O7 2 minus? What will be the structure of that? Cr2O minus. You have only 1 minute to answer the question, students. The structure of Cr2O7. You have a chromium oxygen chromium linkage. Now there is no problem in writing the structure. This one oxygen is gone. How many are there now? 6.
6.
So how will you draw them? 6. You have how much is left? 1 minus O minus O minus. Yeah.
Yes, sir.
This is a dichromate ion, student. There will be again resonating possible structures in this case also, because you will find it has been found the chromium oxygen chromium bond angle is chromium oxygen chromium bond angle has been found to be 126 degree.
Okay.
126 degree. And there are two tetrahedral units which are joined together, and there is a oxygen linkage between the two. Cr group, students, Cr group. And 163 picometer chromium oxygen bonds, 163 picometer is there. And this chromium oxygen is different from slightly this. This has 179 picometer, that one. And all other, this single one's 163. There is a resonance here. So all the bond angles will become equal if we will be able to draw all the resonating structures. Since that is not our point here, so we are not going into that. The important point to note is that are the properties of these. What is the most important property of and use of the potassium dichromate? We are aware that it is used as a primary standard in volumetric analysis. K2Cr2O7 is used as a primary standard. So in volumetric analysis, student, titration. What we do titration? What we are doing titration, student, in titration. And in acidic medium, it acts as a strong oxidizing agent.
Okay.
Acts as a strong oxidizing agent. So it is an oxidizing agent, students. If you have the oxidizing agent means the dichromate is in which oxidation state here? Chromium. Cr2O2 minus is it in which oxidation state? Chromium
+6.
+6. So it is going to chromium 3 plus. So +6 is converted into chromium 3 plus is a stable oxidation state of chromium. How many chromium 3 plus will be what configuration? Chromium 3 plus. Scandium, titanium, vanadium, chromium 3 plus.
Chromium 3 plus will be 3D3.
3D3.
3 plus. 1 will go from S and 2 will go from D. 3D3.
Though that T2G3, we have shown it as a stable configuration.
Achha.
In the case of we have shown it for chromium earlier. So it is going to get reduced from +6 to +3.
+3.
And it is a very good oxidizing agent in acidic solution. The value is also given here. Dichromate 14H6 electrons, it is given 1.33 volt is the standard electrode potential value. So this is positive and it can act as an oxidizing agent. So it is a powerful oxidizing agent. Question has been asked. This question has been asked now. What is the question? The question we have put up here. Describe the oxidizing action of potassium dichromate and write the ionic equations in this question. Important question for the paper. They can ask you a reaction. They can ask you write the, and we have actually done in redox reaction. We have done in 11th class. How do we balance these reactions? How to balance these reactions?
Yes,
The iodide will be oxidized. If iodide is oxidized, then what will happen? It will
Iodine.
Iodine I2. So
I2.
then we have to write the two half reactions and then balance it. And dichromate
Okay.
is converted from +6 to +3.
+3.
Iron is Fe2 to Fe3 plus.
Fe3 plus.
So we have to be able to write these reactions.
Yes, sir.
Then in solution, we have already shown how if it is H2S, then what will happen? H2S, hydrogen will be removed.
Hydrogen release sulfur.
So these equations should be learned by the students. Any equation can be asked in the paper. Question is asked like this. I have given it 4. They will ask only one of them. It depends on the examiner.
Okay.
And repeatedly they are asked give a oxidizing reaction of the potassium dichromate. or give the reaction of potassium dichromate to iodine. Or they give a reaction, complete the reaction. Many ways these questions are given, students. And you can see potassium dichromate, sulfuric acid, nascent oxygen is released, therefore it acts as an oxidizing agent. Oxidizing agent. We want to see the ionic equations we have here. Potassium ionic equations are important. We can write the balanced ionic equation. Balanced ionic equation we have dealt in already in our YouTube videos are there how to balance the reaction. Students are interested, they can learn it. How to balance the ionic reaction. Half reactions are written, then electrons are cancelled, and then you get the complete balanced ionic equation. Potassium dichromate in
Okay.
the presence of acid is giving chromium 3 plus iodine to iodine, then 6 electron cancelled. So that this is the overall reaction which we have shown. This is what is required for the exam. If I can't remember this, I have to see the half reactions and cancel. Then it will take me more time. I'm not showing you how to balance the reactions, but this is the correct equation. How it oxidizes iron 2 to iron 3, student. These are the reactions again. Half reactions, balance and cancel the electrons. How potassium dichromate oxidizes H2S2 sulfur. Important reactions. Three equations we have given here to show that. Question was also this, give an equation to show that, right?
Okay.
Equation to show K2CR2O7 as an oxidizing agent. So we have in acid medium in H plus. So we should be able to write the equations. At least one should be known to us, students. Okay.
Okay.
Then note down. I am proceeding further, students.
Yes, sir.
The next important compound I am talking is potassium permanganate. I said there are two important compounds, potassium dichromate and potassium permanganate. When I say KMnO4, student, that means K plus MnO4 minus. What is the oxidation state of manganese here?
In KMnO4 minus, KMnO4 minus it will be 1 plus x minus 8 is equal to minus 1
Plus M. We have already seen manganese in the 3D series shows the highest
plus 7.
value of the oxidation in the 3D series, whereas in the complete, that is osmium, we have shown plus 8. Manganese shows plus 7 oxidation state, students. Now here again, the method of preparation, when I say that this is an important question, student, because they have asked it many times. Again, there is a ore, you see, which is called pyrolusite ore. Pyrolusite ore, I am saying, students. We should be able to know the formula of that. MnO2. Now, in the potassium dichromate, what I have used is, which ore I used? Chromite ore.
Chromite ore.
And what was the formula? FeCr2O4. FeCr2O4.
Cr2O4.
What I did with that, I converted that into chromate ion first, and then sodium chromate to potassium dichromate.
Chromite.
Now you have MnO2. What I did there, used an alkali and oxygen and fusion. Fusion means alkali and oxygen heating, fuse it. Here I am again saying fusion of the again I am saying I am doing fusion of this MnO2 pyrolusite ore. So again I am using potassium hydroxide as an alkali and oxygen. Is fused with alkali metal hydroxide such as KOH in the presence of oxygen, student, and it will give here K2MnO4. This is the first reaction. This is my ore fusion. One thing is important, that these ores, I am fusing it. And fusion means heating with alkali and oxygen or NaOH or Na2CO3. But some alkali is there.
Okay.
Alkali is there, student. Alkali and oxygen, heat it. That becomes fusion. And in the fusion process, what I am getting, you are getting here K2MnO4, student. K2MnO4. So this is potassium manganate. What is the name of this?
Potassium
Potassium
manganate.
manganate. And again, these are highly colored, student. What is the color of this? Color is important because they will give a question on the base of color, which has been asked. On the base of color, they have asked this question. So fused with KOH to give dark green. This is dark green in color. Potassium manganate. And this is the formula is K2MnO4. K2MnO4 means what? MnO4, how much? How much? 2 minus. This is 2K plus. What is the oxidation state?
It will be
Plus 6.
+6.
And what I need is MnO4 minus. That is plus 7.
+7.
So then what we have to do? We have to further oxidize it.
Oxidize.
So actually what happens is in the presence of acid, it disproportionates. And we told you
Okay.
now the middle oxidation states are not very stable.
Yes, sir.
They will disproportionate to lower and
Okay.
higher. So here what happens, students, that in acidic solution or in neutral solution, K2MnO4 undergoes disproportionation. There is a disproportionation reaction and it gives you MnO4 and MnO2. So what you get, students, you are getting KMnO4, that is potassium permanganate, student, potassium permanganate. And
Okay.
therefore, in that oxidation state is plus 7. And what is the result of this? When you will see this, how will you know that this has undergone disproportionation? There will be some change in the color, students. What I will see change in color here. What is this color? Dark green.
Dark green.
And what is the color of MnO4? Purple.
Okay.
Purple and dark green. These colors we have to be able to remember because this is a question based on color, student. Again, I'm putting it. KMnO4 you have seen in the chemistry lab. Potassium permanganate. To remember it, potassium permanganate per purple color. Purple.
Okay.
Purple. And manganate, manganate, manganate. So this is dark green. Potassium, dark green color. So there is change in color from dark green to purple when you will get potassium permanganate.
Okay.
Colors are important. Colors are important to identify the products. Many times they will give you a reaction that an ore is being fused with alkali and what you are getting is dark green colored student liquid which on treatment with acid produces a purple color.
Okay.
Write the equations. Write the equations. So we should be able to know what reaction he's talking about. Such questions were given in the paper. And in many cases, competition also, they have asked. These two compounds are extremely important. I'm again and again saying KMnO4 potassium are extremely important question for the paper. Students, one question is coming. Another possibility is that K2MnO4, we can do electrolytic oxidation. If I do the electrolytic oxidation, then what will happen? What ions you are having? You have 2K and MnO4, 2 minus ions. So what will happen at anode? What happens? Oxidation takes place at anode. This will at anode, and this will go. There will be H ion also in the solution. So what will happen? Cathode and anode. At the anode, MnO4 2 minus is oxidized to MnO4 minus.
Okay.
This has been used. This has been used. For electrolytic method has also been used. They can ask anything. So whatever is in NCRT is the minimum. NCRT for 12th we have to learn it. There is no other way. Anything written, what is the problem in NCRT? He writes only one word, and that word has some good meaning. Students don't take time for that. So one word is written. We should understand that. And the question becomes on one word, then students are in trouble. And if you are in competition, you go 10% more than that, 10% more than that. There the words are actually certain chapters in certain books, so be careful about that is what I'm saying. So if this method is given in the NCRT, then we should know that what are the structures and what type of compounds are being formed, students. So what we are getting, student, two important things. What is the first thing? Let me say what I'm getting. Dark green. Which one is dark green, student? Dark green. Manganate ion, MnO4 2 minus. What is this? Manganate ion. Now the question, what is the structure of this? Draw the structure of manganate ion. Question has been asked.
Um,
Draw the structure of the manganate ion, student.
then-
You know it will be sp3 hybridized. So the tetrahedral shape is there, green.
Yes, sir.
So what will we do then? Always we said, okay, if something is tetrahedral, then what we do? You can put anyway, it doesn't matter, all are equal. And there are two minus, so that is the reason we are putting one minus. There will be many resonance structures of this. Always I'm saying there will be resonance. And you, one is interested, one can try to draw. Many resonance possibilities are there because there are all the oxygens are equal, student. You cannot say this is double or this is single. They can be anything. This can be double, this can be single. So whatever possibilities are there, maybe 5, 6 or whatever, 6 structures or more may become possible in such cases. So there is a tetrahedral manganate ion which is green in color. And what is the color of the other one? You are saying this is manganate ion. Now I am saying what permanganate ion. Permanganate ion, students. Permanganate, purple color. That brinjal color jamun. Permanganate ion. Permanganate ion. What will be the structure of this? This is MnO4 minus 1. So what
Yes,
will
sir.
be the difference? No problem. Only one minus is there. So 1, 2, 3, 4. Okay. We're putting 3 double bonds and you have one minus. Okay. And there will be, I can see there are possible resonance structures. This can be single, this can be single, this can be single, this can double. So there will be resonating structures. So you have purple and green color, students. structures are also asked in the papers, have been asked. So we have given you. Students, you can't do the mugging of everything. That's my point. A tetrahedral structure, sp3 hybridization, then oxygen double bond and oxygen single bond, then single bond will have a negative charge. That we know. That's why we are doing it. When we do 2-3 times, then things become easy for us. If we have not done it on the notebook ourselves, then the things will become very, very difficult in the exam. That we are sure. Okay.
Okay, sir.
All right. So far, so good. Going further. Here we have shown you the structure which we have drawn. Important. See the colors have been shown. And certain properties, people, they give you the reactions or ask action of heat. For example, they say in the exam KMnO4 heat, write the reaction. Do you have to complete these reactions? On heating, it decomposes, student, it decomposes. You can see KMnO4 was prepared from K2MnO4 and it decomposes to K2MnO4, MnO2 and O2. So this reaction is taking place. You can see that, and these are the structures and the colors, purple and green, purple and green. So if we represent the reduction of permanganate to manganate ion, students, the electrode potential values are shown. So again, what it shows, students, that MnO4, Mn plus 7 oxidation state. That plus 7 oxidation state. It can go to, students. Here, what is the oxidation state? Plus 6,
+6.
plus 4, and plus 2. Therefore, it can act as an oxidizing agent. And they will say question, show, give a equation, give a chemical reaction, give a chemical reaction or an equation that KMnO4 acts as an oxidizing agent. Is a favorite question, students, in the exams. For example, same thing here, iodide is being oxidized to iodine and MnO4 is converted into Mn2 plus. If required, acidic medium is there. If you can see that. We can write the two half reactions. As I said, we have given you how to balance the reactions. If complete balancing is required, we will spend time and do it. Otherwise, I don't recommend cramming of the equations. Only products are important. And sometimes they give reactions and ask you to write the products. What do they say? Write the products. So some equation is given, write the products. You have to complete the reaction, students. They may give one or two things or say write that, give the two important products.
Okay.
Name of the two important products. We are not even asking you to balance the reaction, student. Two important. Then you know iodine will be there. And the second you know which will be there. Mn will be reduced
And
to Mn plus 2.
plus.
So that's all we have to write.
Okay.
They make it, your job easy, but those only if you understand these things, you will be able to get the right products. Such questions are repeatedly asked in the paper with some choices, students, that they can give different choices to you. So here are some of the reactions in which we have shown that they can act as acids in acidic medium as well as in neutral or alkaline medium. Student, KMnO4 acts as oxidizing agent. Important. One question can be there in the paper. Neutral, acidic, alkaline. And some of the important reactions you have seen about reaction with iron is also important because ferrous is being oxidized to ferric. And you see what is the color of Fe2 and Fe3 ion, student. Color is important because here sometimes questions will be based on the color. Color is changing. Iron 2 plus are green in color.
Green.
And iron 3 plus are yellow in color.
Yellow.
Important point. If you will take ferrous chloride and ferrous Cl3, then you will see some color changes. Green to yellow, green to yellow. Iron 3 plus are green, green, green. And a dichromate, chromate ions, when we are talking of yellow color, yellow color. When I talk about chromate ion, CrO4 2 minus, this was yellow. Chromate ion was yellow in color.
Yellow.
But there is one chromate which is not yellow.
Okay.
Ag2Cr4 is not yellow. No, all others are
Okay.
yellow. I think these are red in color. Silver chromate. Silver chromate is red. All other chromates are yellow in color. Certain, when we keep on doing the reaction, student, what I am trying to teach to my students only one thing. We have to pay attention to every word, or we will miss something for the paper. Very important point. One thing is doing the equation, and another thing is paying attention to each and every word which is written. That is what is decoding we are doing. I can say, okay, this is the reaction, okay, finished. That there is a reaction is given in the book, no problem. But when I have to decode it, I have to see what is the change in oxidation number, what is the color of the change, students, because questions are based on that. Wherever some color are markedly changed, we must learn them and we should be able to compare them. Structures
Okay.
is up to the examiner what question he will give. Preparation, of course, is important. One question is always there. But instead of preparation, if he gives only draw the structure of chromate, then what the question is up to him, the choice is there. So because 1 mark question has to be given. That's the thing. There is a lot of variety of the question, but those students who will pay attention to each and every word, they will be able to do it. Student with great confidence. In our lectures, there will be a lot of question answer sessions everywhere. Every lecture will have plenty of questions and answers. And wherever need is required, we are saying pay attention, student. What is the precipitate? What is the color? What is the change in color, student? What is the change in oxidation state from one to the other? What is the disproportionation reaction? All these are important questions for the paper. So here oxalate ion or oxalic acid titration with potassium permanganate is familiar. Titration of the chemistry lab, important. The oxalic acid is being oxidized to the carbon dioxide. See how much is the change in the oxidation state of the carbon. Hydrogen sulfide, sulfur is precipitated. Sulfides then are oxidized to sulfates. As how much is that? +4 to +6. Nitrites, so +3 to +5. Nitrate. NO2 -2. NO3 minus. What is the oxidation state? +3 to +5.
+1.
This is how we
Yeah.
learn. This is how we see that. What is the state which is undergoing? I -2, I2 means -1 to
-1
0.
to 0.
So all this is a concept to be learned by the students. And manganese salt is oxidized to MnO2. Mn2 plus is getting, what is happening? Mn2 plus is the manganese sulfate or manganese, it is going to MnO2. So what is that? +4. So all these change in oxidation states, acid medium, these are some of the examples where we have shown you that potassium permanganate can be used as an oxidizing agent, students, in neutral, acidic or alkaline medium. All one reaction can be asked in the paper.
Okay.
So with that, we end up the two important reagents which are being used in analytic chemistry. The chemistry labs, potassium permanganate as well as potassium dichromate, and they are finding used for KMNO4 as texture fibers and bleaching and other type of bleaching of the wool, etc., and strong oxidizing agents, etc. They are
Okay.
used in the labs, and preparation properties and the structures of the ions and the colors are to be learned by all the students for doing good in the coming examination. Okay, then good night. We will meet you in our next class.
Okay. Thank you, sir.
Okay.